Hello dear friends, welcome to Gate Academy Global. So before starting today's session, I would like to take the feedback as well as concurrence regarding the quality of audio as well as video. If it is perfect, just write perfect over the live chat and then we are ready to go. My dear friends, the agenda behind today's video and the series of the engineering mathematics which has been running has been very clear and precise. Taking the reference of the questions which have come in GATE year of 2021, we are building the concept for GATE 2022. And yes, the questions have been taken in terms of their topics. So in last video, we were discussing about the questions which were coming from the topic called complex variable, but we could not finish all of the questions in last video. So in the same sequence, let me take few more number of questions from the complex variable itself. Yes. So the agenda must be clear to all of us. We are going to take few number of questions from the complex variable. So in yesterday's class, we had around 4 number of questions from the complex variable. Now in today's lecture, we are going to take the 4 number of questions from the complex variable, and total 8 number of questions were appeared from this topic in GATE year of 2021. Once we are done with this 4 number of questions, and if the time permits, we would be taking around 3 to 4 more number of questions which are coming from the basic calculus, the integral calculus as well as differential calculus. So without getting delayed, let me straight away jump into the problem. So let me show the problem. Just a minute. So may I know the quality of video and audio, is it perfect? If it is perfect, just write perfect over the live chat. So at least I'll have a fair idea. So the first question comes from the page number 14. Here goes the first question. This problem has appeared in GATE Electronics year of 2021. Yes. Let me see what the problem states. Consider the integral, it has been a closed line integral of sine of x divided by of x square within the bracket x square plus of 4 dx, where c is the contour clockwise oriented circle defined as mod of x minus I is equals to 2. Then the value of the integral is, the 4 different options were attached along with this problem. The option A was pi divided by of 8 getting multiplied with the sine 2i. The second option was pi divided by 4 getting multiplied with the sine of 2i. The third option was minus pi divided by 8 getting multiplied with the sine of 2i. The fourth option was minus pi by 4 sine of 2i. Anyways, try to get the exact most answer for this given problem. My dear friends, it was not a well designed problem. See, what are the different problems this question was containing? Many of the students had one doubt. Sir, as they have made a function with contains of x, so whether it is a real function? No, my dear friends, they were treating x as z. So that is the first thing where major of the student would do mistake over this problem. But anyways, you can say the x has been a complex number. Because in this problem they want to talk about the Cauchy's integral, and they talk about the Cauchy's integral. In that case, the function what we used to have a complex function, and for making a complex function the variable has to be a complex variable. It should not be a real variable. Yes, so first thing which must be taken into the consideration where the x is a complex number. And if the x is a complex number, definitely in future when we will be calculating, the x would have the 2 part. It could have its real part as well as it can have its imaginary part. So the real part has been precisely taken as A and imaginary part has been precisely taken as B. That's the first thing. Similarly, where C is the counterclockwise oriented circle defined as, now the x has been a complex number, that means it would have its real as well as imaginary part, or in short you can say the x would have abscissa as well as ordinate. May I know what would be its abscissa and as well as ordinate? So here it goes, a plus of jb minus of I is equals to of 2. Yes, what I would be doing over here, all of the real part would be segregated one side, that is simply A, and similarly all of the imaginary part would be segregated another side, which would be B minus of 1, and you will take a mod of it and has to get compared with 2. Yes. Once you will take its determinant, obviously it has to be root over of square of the real part, square of the imaginary part. So end of the day, after taking its determinant, the result what we get in a hand is simply going to be a square b minus of 1 to the power of 2, and here goes 2 square. Here goes 2 square. What it indicates? It indicates it is a perfect equation of the standard circle, where the center, keep in mind the A is a part of abscissa, and similarly B is a part of ordinate. So that's the first thing where many of the students would have bit amount of confusion. So here the x has been a complex number, and hence it would have the two parts. A, which can be called as abscissa, and similarly B could be called of y. Yes. So here we get to know about the character of this circle. The circle has been centered along 0, plus 1. The center has been at 0, plus 1. And if we'll talk about the radius of the circle, the radius of the circle has been r is equals to of 2. R is equals to of 2. Yes. Till this point, probably each and everything must be clear to all of us. See what is happening hereafter. My dear friend, whenever you go for the Cauchy's integral, what you do? You first see all of the singular points which are enclosed by the given closed line integral. I repeat, whenever you calculate the closed line integral using the Cauchy's form of the integral, what you do? First you look for all of the singular points which are enclosed by the given closed line integral. My dear friends, this has been a closed line integral, which is a circle, has been centered around 0, 1 and have been a radius of 2. That's the first thing. That means the closed contour is known to me. And from that closed contour, which are the singular points are getting enclosed. May I know what does it mean by the singular point? The singular points are the points where the complex function stands for the continuity as well as differentiability, or I can say the point at which the function becomes non-differentiable and non-continuous. Where it happens? It happens at its pole. What does that mean by the pole? The pole is nothing but the roots of its denominator. So obviously, once you focus over its denominator, it has been a polynomial x square within the bracket x square plus of 4. So what you would be doing over here? You would be searching the singular point. Yes. x square plus of 4 has to get compared with 0, and as it has been the multiplication, you can compare x square with the 0, x square plus 4 is equals to 0 exclusively. So the result what we get, it's simply going to be x square is equals to 0, and the second result what we get, it's simply going to be x square plus of 4 is equals to 0, agreed? So till this point, probably each and everything must be clear to all of us. Yes, no? See, if you will take the square root towards right hand side, the x would have the two values which are 0 and 0, and similarly the x square plus of 4, when the 4 goes towards right hand side, the x would have the two values, that is nothing but plus 2 as well as minus 2. Yes, plus 2 as well as minus 2. Done, no? So that is what, just a minute, not plus 2 and minus 2. It would become minus 4, no? Minus 4. You will take a square root of minus 4. So here you will be having the two value, plus 2 iota and minus 2 iota. So how many number of singular points we have for this complex function? Obviously, the 4 number of singular points we have. One is at 0, the another repeated at 0, the another was at plus 2i, and the another was at minus 2i. But anyways, now you have to look into, out of this 4 number of singular points, which are the singular points are getting enclosed by this circle, Yes, if none of them is getting enclosed, by default its closed line integral would be 0, and one is getting enclosed, you have to take the residue along that point. If 2 is getting enclosed, you have to take the residue along that point as well as first point, so on and so forth, Yes, till this point probably each and everything must be clear. Anyways, I am just going to rub it out. So nobody should have any doubt. Many of the times it has been seen, rather taking z, they used to take x. Yes, the x has been a complex number, and hence it would have its real as well as imaginary part. The a is in place of x, b is in place of y. So you can say a is a abscissa part and b is nothing but the ordinate parts. And yes, it is fabricating a circle. So till this point, probably each and everything must be clear to all of us. The same thing I have wrote over here. We have got a function f of x. At very beginning, we were focusing over the calculation of its pole. What I did, I took its denominator, compared with 0. The 4 number of poles we got it, where 0, 0, or I can say I have the repeated pole at 0. Then we had 2i as well as minus 2i. Once we are done with this, we'll move forward. Again, we'll recall which type of closed line integral you had. So it has been clearly given. It was x minus of I. The x has been taken as a plus of I beta minus of I had taken mod. So end of the day, the result what we got it now. We had a circle. We had a circle, which you can recall. We had a circle. It was centered along 1, 0 and had the radius is equals to 2. Had the radius is equals to 2. So you yourself would be able to understand the center of this circle has been 1, 0, which could be simply written as I. Yes, if you say 1, 0, not 1, 0, just a minute, let me go back. The center of the circle has been, okay, the circle of the center has been 0, 1, sorry, 0, 1, yes. The center of the circle has been 0, 1. If you'll say 0, 1, my dear friends, the real part is 0, imaginary part is 1. So simply it could also be written as plus of 1, it's getting multiplied with the iota. So that is why the center of this circle has been iota. The center of this circle has been iota. Agreed till this point? The center of this circle has been iota, and now you will take a radius of 2, and once we take the radius of 2 and if we draw a circle, obviously over the y-axis it would be crossing to 3i, as I plus of 2i would become 3 of I, and similarly the 2i would get subtracted with the I and it would be crossing through the minus of I. So now if you will recall the 4 number of poles you had, which were 0 and 0, or I can say the repeated pole at 0, then we had 2 of I, then we had minus 2 of I. So may I know out of 4 number of poles which are getting encircled and which are not able to encircle? My dear friends, obviously 0, 0 is getting encircled because this poles has been kept somewhere here. They have been repeated inside. And similarly, out of the rest 2 number of imaginary poles, the 2i is getting encircled. Yes, that's a plus 2i. The minus 2i is not getting encircled. That means in future when we will be calculating the closed line integral, we had to take the residue along 0, which has been repeated, and similarly 2i. We don't have to take the residue along minus of 2i. So till this point probably each and everything must be clear to all of us. So if we would be searching the closed line integral of the complex function sin of x divided by of x square into x square plus of 4, that would be equals to of 2 pi I, and now you will be taking a residue at x is equals to 0, and similarly you will be taking the residue at x is equals to of 2i, and whereas minus 2i could not be encircled by this closed contour, definitely that would be taken out. So in the same procedure we had to go ahead. So first you must be knowing, if you talk about the closed line integral of a complex function fx dx, that would be simply equals to of 2 pi I discrete sum of the residues at different poles which are encircled. The first is at 0 and the second is at 2i. Yes. So first focusing over the residue of the function at x is equals to a, where poles are repeated at x is equals to a m number of times. So may I know what used to be the formula for it? The formula used to be 1 divided by m minus 1 factorial, and at inside there would be a differentiation m minus 1 times of x minus a to the power of m f of x. Otherwise, in general, we used to take this as a f of z, we used to take this as a z minus a, we used to take as it is 1 upon m minus 1 factorial, 1 minus m1 factorial. Till this point, probably each and everything must be clear to all of us. Now we had to get the residue at x1 is equals to 0, and that too it has been repeated. How many times? It has been repeated 2 times. That means the value of m has to be taken as 2. So why don't we start feeding the data over here, my dear friends? So here the m becomes 2, so it becomes 2 minus of 1 factorial. Here it becomes d to the power of 2 minus 1. That means only once the differentiation would be taken place of which component? X minus of 0 to the power of 2, that would be simply x square, and again the complete f of x would be called back, which is nothing but the sin x divided by of x square within the bracket x plus 4. Yes. So what is happening over here? This x square would go off. And now you will be taking the differentiation of sin x divided by of x plus 4. Obviously, it would be differentiation of a divisor component. You can assume the sin of x as a numerator's function, and you can assume x plus 4 as a denominator's function. May I know what used to be the differentiation? The differentiation used to be, there would be the square of the denominator. Denominator would come as it is, there would be a differentiation of numerator, and now the reversal process takes place. The fx would remain as it is, there would be a differentiation of denominator. There would be the differentiation of denominator. Till this point, probably each and everything must be clear to all of us. So what happens? The x plus 4 would become x plus 4 square. Next, x plus 4 would come as it is. There would be a differentiation on sin x, which would become cos x. Minus of sin of x would be repeated as it is. There would be a differentiation of x plus 4, and which would be simply 1. Which would be simply 1. So that is what I have done it over here. That is what I have done it over here. See. That is what I have done it over here. You can see very well. See, x square is going out, and the differentiation of sin x divided by x plus 4 has to be taken place, and that differentiation would be taken place with its property of the division. So the result what we are getting now, it's gonna be x square plus of 4, just repetition of the denominator, differentiation of numerator, minus of denominator would be as it is, and there would be a differentiation of 6. So the result what we get, it's gonna be x square plus of 4 cos of x minus of 2x sin of x divided by x square plus of 4 to the power of 2, and that value has to be calculated precisely at its pole itself, which is nothing but the x is equals to 0. So once we'll start feeding the data, this would become 0, this would become 1, this would become 0, this would become 0. So at numerator you will be having 4, which is getting multiplied with 1, that is simply 4, and at denominator you will be having 4 to the power of 2, that is 16. So the result what we get, it's going to be 1 upon 4. The result what we get, it's simply going to be 1 upon 4. So till this point, probably each and everything must be clear to all of us. Yes. Now next what we had to do, we also had to calculate the residue at x2 is equals to of 2i. Why? Because the x2 is equals to 2i is also getting encircled by the given closed contour. Now it is no more repeated. My dear friends, many of the students think this is the formula only valid for the repeated pole. No, my dear friends, it has been a standard formula which can be applied for the repeated as well as single pole. When the pole is single, the m would be 1, and as the m is 1, it would become 0 factorial, which is simply 1, and now there would not be any differentiation because its power becomes 0, and here it becomes x minus a to the power of 1 put together. The residue becomes x minus a f of x at x is equals to a, which used to be the simplest form of the residue, which are non-repeated. So you can say it is a type of standard formula for the calculation of the residue, repeated or non-repeated. Yes, so the same formula would be called back. Only one difference you will be having. What it is? May I know what it is? A was 0 earlier. What I am saying, the A was 0 earlier, but the A would be 2i precisely. So here it becomes x minus of 2i. Yes, and here you will be calling back your f of x. What was the f of x? The f of x was the sine of x divided by of x square. Within the bracket you had x square plus of 4, which is nothing but x plus 2i into x minus 2i in terms of their factors. And now this value has to be precisely calculated at x is equals to of 2i. At x is equals to of 2i. The differentiation of, anyways, we'll see Nili Sai Kumar what you are saying. Let me go back. Let me complete this problem once, then we'll be going back. Yes, till this point, probably each and everything must be clear to all of us. Now here goes. The residue at x2, which is nothing but the 2 of I, has been found as a minus sine 2i divided by 16 of I. So end of the day, the basic focus of this problem was to calculate the closed line integral of f of x dx, which used to be 2 pi I times of discrete sum of the residues of the different point of pole which has been enclosed by the given contour. So it used to be at x1, which is nothing but 0, x2, which is nothing but 2i. The values are clearly given. This value was 1 upon 4. This value was minus sine 2i divided by 16i. So the end of the day, the result what we get, it's gonna be this. Yes, till this point each and everything must be clear. Find it out fast. So the best most answer which we are getting for this problem is gonna be pi I divided by 2 minus of pi sine 2i divided by 8. One of the blundermost thing which has been done along with this problem. Such a huge problem it is. How much time it's going to take? The huge amount of time it's going to take. And once you'll see their options, once you'll see its options, nowhere it is being present. Nowhere it's been present. And as far as the answer key which has been released by the gate body, the answer they have given what you just recall. You can just recall the pi I divided by of 2. The answer what they have given, it's minus of pi divided by of 8 7 of sine of 2i. What's the mistake they would have done? What's the mistake they would have done? My dear friends, they forgot about this component. They forgot about this component, that even x is equals to of 0 is also getting encircled. X is equals to 0 is also getting encircled. So already we have challenged this problem. We have already challenged this problem, and probably in future this problem is going to be corrected, and probably they would be offering marks to all. They would be offering marks to all. So till this point probably each and everything must be clear to all of us. Yes, could you understand what I am saying? But we do not expect, my dear friends, such a huge crisis we have for the employment, but still the gate body is doing such a miserable mistakes. And I would say the student who are well qualified, the student who have a good grip over the technical knowledge, they must have gone till this complete process and they could have got the same answer. How much time they would have spent? How much time they would have been lost, you can say. Why? If they give marks to all, what would happen at last? If they give marks to all, what would happen at last? My dear friends, nowhere is going to be benefited, and specifically the student who have given around 4 to 5 minutes to a single problem, they are going to be sufferer. They are going to be sufferer. Sir, I learnt up to Laplace transformation only. That's why I am not answering. Yes. So such a miserable mistake has been taken place, and yes, it has been the problem from the electronics. And the answer which was offered by them is minus pi by 8 sine of 2i. So you yourself would be able to understand where mainly they have done mistake. While calculation, they have forgot even the x is equals to 0 was a pole which was getting encircled by the given closed contour. And that is why they had the wrong answer. They had the wrong answer. So my conclusion for this problem would be, none of the option is matching. The question is not in proper form as per their options. So this question must be considered as marks to all. But I would always say, whenever you used to have marks to all, it is a big setback to the student who have attempted that problem to its merit. And yes, it has been the same. It has been the same. Such a huge mistake the IIT bodies are doing. I am not sure why they are doing so. This mistake should not be happening to even students also. This problem must go to the marks to all. And as far as the answer key which has been released so far, once you'll see that answer key, they have given the answer as option C. And yes, we have challenged this problem, and probably on 18th they are going to finalize the final answer key. There the answer must be marks to all. And even few of my students, what they have done, do you know that? Few of the students, once they got the complete answer as the answer which we have just calculated, end of the day when they saw the option A, B, C and D, nowhere they got the correct answer. So end of the day they thought they did mistake somewhere. What they did? End of the day they did not mark either A, B, C or D. But in result of that, they lost around 5 to 6 minutes, because yes, this problem would take around 5 to 6 minutes to smash it completely. Agreed what I am saying? Could you understand? Could you understand, my dear friends? So I would request to each one of you who are preparing for GATE 2022, if you get this sort of situation, just do one thing. You can even put the nearby answer. That's the first thing, or otherwise leave that problem, because that problem is just going to suck the amount of time what you have, and probably that sucked amount of time would be making you out from the gate. That mistake you should not be doing. Yes. So in the same sequence, I am going to take the next question, and this question comes from, just a minute. And that question comes from the page number 29. Page number 29. Yes. For the better understanding, let me go up. This problem has been the problem. This problem has been the problem from mechanical engineering forenoon session. And again, it has been the problem of complex variable. So focus over the problem and try to get this answer. See what the problem states. The C represents the unit circle centered at origin in the complex plane. What I am saying? Let C represents the unit circle centered at origin in the complex plane. And complex variable z has been x plus of iy. The value of contour integration, it has been a sign of closed contour integration of cos hyperbola 3 of z divided by 2 of z dz, where the integration is taken counterclockwise is. The options were given as 2 pi I, 0 and 2. 0 and 2. Tell me what would be the best most answer for this given problem and which approach you will be using for this problem. My dear friends, it has been a same problem which we have been dealing again and again. It has been a problem of Cauchy's form of closed line integral. I may write it CCLI. At very beginning, what you do? You just used to have a little bit understanding of the closed contour which has been provided along with this problem. And that closed contour has to be drawn over the z plane, which used to have the real axis as x and similarly imaginary axis as y. It has been clearly given. The C represents the unit circle centered around the origin. Yes, you would be having a circle which is centered around the origin. Agreed? And has the radius is equals to 1. That means it would be crossing through. 1, 0 or simply, just a minute, 0, 1, or simply it can be written as I. Similarly, 1, 0, which can be simply written as 1. 0, minus 1, which can be simply written as minus I, and similarly minus 1, 0, which can be simply written as minus 1. Yes. So over the 4 different axes, it is going to be intersected at 1 I, minus 1 and minus I. Yes. Now what we do, whenever we look into the closed line integral, we just focus over its poles, because the poles are the points or the poles are the values of z, where the complete function f of z becomes singular, non-analytic. How do we get its pole? The roots of the denominator of the complex functions are called poles. So how many number of poles you will be having? Just search by comparing 2 of z is equals to 0. So the value of z what we get for this problem is simply going to be 0. So we had only one pole or one analytic problem for the one analytic point for this complete function. Now the next thing comes when we calculate the closed contour line integration using the Cauchy's theorem. The fz dz used to be equals to of 2 pi I. Will it be positive? Will it be negative? That solely depends over the direction of the contour, whether it's a counterclockwise or whether it's a clockwise. If it is counterclockwise, the value is to be taken as positive, and similarly, if it is clockwise, the value is being taken as negative. Yes. Now, here you will be having the discrete sum of all of the residues which are enclosed by the given contour. Yes. So only one pole we have, and yes, it has been enclosed. So end of the day, you can say it would be 2 pi iota or 2 pi j you can write, and you had to find the residue of the function at z is equals to 0. Whatever the answer we get, that would be the final answer. Anyways, how we get the residue? We have seen so many number of times. Probably 3 to 4 number of problems has been taken day before yesterday, and even one problem has been taken in today's video itself. So what would be my approach? My approach would be, my dear friends, this complete function has to come as it is. Yes. Now the z has to get multiplied. If you do not understand, now do one thing. Half can be taken as a constant out. Without making any mistake, you can took half outside. So here what's happening over here, I know many of the students would have doubt at that point. So you can take 2 outside now, 2 outside, and just you are going to deal with the function cos of hyperbola 3z divided by z. So here it's gonna be the z would get multiplied with cos of hyperbola 3 of z divided by of z. Once we do multiplication, end of the day we had to feed z is equals to 0. Z is equals to 0. Whatever the value we get out of this, that's gonna be the closed line integral of this given complex function. Yes. The same thing has been made. Yes, I have taken the reference of this unity closed loop, circular contour. Yes, end of the day we were calculating the residue at z is equals to 0. What was the approach? Yes, the z has to get multiplied, the z got out. The value what we get, it's simply going to be half. The half has to get multiplied with the 2 pi I. The end of the day, the result what we are getting is simply going to be pi I. Simply going to be pi I. So if we'll talk about the closed line integral of fz dz, obviously for this given problem is precisely equals to of pi I. So may I know whether the closed line integral really depends on what I am saying, whether the closed line integral of the function f of z really depends on the structure of the closed contour. No, it does not depend on the structure of the closed contour. It depends only on the two factors. First, the direction of the enclosement, whether it has been a clockwise or whether it has been in what counterclockwise. Secondly, whether that structure is going to encircle your singular point or not. So what I am saying, in future if you have this sort of problem, rather having a circle, if you have a square, rather having a circle, if you have a square, still the direction has been counterclockwise, you will be getting the same answer. If you want to write somewhere, you can write it very clearly. The closed contour integration does not depend on the structure of the closed contour. It just depends on the direction of the closed contour and how many number of non-analytic point or the singular point has been enclosed by that closed enclosement. Even it could have been ellipse also. It could have been ellipse also. So till this point, probably each and everything must be clear to all of us. Yes. Now in the same sequence, let me take the next question. Here goes the next question. And I would expect each one of you would be able to solve this problem out by yourself. I'm just giving the frame of time of 2 minutes to solve this problem. It is one of the simplest form of the problem, usually do come in class 11th and all. And this has been the problem. Just a minute. This has been the problem. Yes, this has been the problem. Tell me what is the best most answer for this given problem. Let me see what the problem indicates. Value of 1 plus of iota to the power of 8, comma, where iota is equals to of root over of minus I. Obviously, as per the definition, the iota is being defined as a square root of minus 1 is equals to, 4 options are given, 16, 4, 4i and 16 of i. Tell me what would be the best most answer for this given problem. What would be the best most answer for this given problem? I would just give around 2 minutes to solve this problem out. Tell me what would be the best most answer. What would be the best most answer for this given problem? Tell me what would be the best most answer for this given problem. What would be the best most answer for this given problem? My dear friends, the approach is clearly known to me. See what I would be doing over here. I plus 1 plus I to the power of 8 could have been written as 1 plus I to the power of 2 to the power of 4. Why I am doing so? See, when the square identity is being applied with the 1 plus I, the resultant would be much simpler in form. So what I am saying, 1 plus of iota to the power of 8 could have been written as 1 plus of iota to the power of 2, and it has been completely raised to 4. Raised to 4. Agree? Nobody should write like 2 to the power of 4. No, that is not the correct way. See what is happening over here. If you'll expand only and only part which is inside the curly bracket, the a plus of b to the power of 2, that used to be a standard identity. What used to be the result out of it? It becomes 1 to the power of 2, which would be simply 1. Then it would become plus of iota square, which would become minus of 1. And at last, here it becomes 2 times of I. 2 times of I, which has been raised to 4. Which has been raised to 4. Yes. See, then what's the result is going to come from here. 1 and 1 is going to be cancelled out. The 2 to the power of 4, which would become 16, and here it becomes I to the power of 4. I to the power of 4, which used to be 1. So the result what we get from this problem is simply going to be 16. It's simply going to be 16. So I would request to each one of you, if iota is known to me, which is nothing but root over of minus I, you must be knowing the value of I square. If you'll take square both other side, definitely square root goes out. Here the result what we get is simply going to be minus I. If you take I cube could have been written as I square. I square is nothing but the minus of 1, and which is being lefted with I and it's getting multiplied. So simply it would be minus of I. Minus of I. Similarly, if we talk about I to the power of 4, what does that mean by the I to the power of 4? I to the power of 4 could have been written as I square into of I square, where the I square stands for minus of 1. Minus of 1 is getting multiplied with the minus of 1. The result what we get for this problem is simply going to be plus 1. Plus 1. So from here onwards you can say I to the power of 4n is simply going to be plus 1, where the n belongs to the family of the natural number. N belongs to the family of the natural number. Yes. In the same sequence, we are going to take the next question. Just a minute. In the same sequence, we are going to discuss about the next question. Yes, again, it has been a simplest form of the problem, usually which we deal in the class 11th. This problem has been appeared in production engineering in the recent year of GATE paper. See what this problem indicates and what would be the best most answer for this given problem. This is the problem is. This is the problem is. See what the problem states. If 3i plus of 1, which is getting multiplied with x, plus of 4i plus of 4, which is getting multiplied with y, plus 5 is equals to 0, with x comma y being real and iota is being a complex number, which we call it root over of minus of I, minus of 1, then the value of x has to be calculated, and that has to be calculated till the first decimal place. First decimal place. My dear friends, it has been a problem of complex equality. It has been a problem of complex equality. My dear friends, towards left hand side you had a complex function, towards the right hand side you had a complex function, and if left hand side and right hand side has to be same, its real as well as its imaginary part has to be very same. As we have been discussing about this small concept in case of 11th class, what I am saying, if you had a complex function or the complex number towards left hand side, let's take it as a x1 plus of I y1, and similarly you had a complex number towards right hand side and which has been x2 of I y2, and in between there has been an equality sign. That means both of the complex number have been same. And if both of the complex number would be same, my dear friends, that's possible only and only their real number exclusively and their imaginary number exclusively has to be very same. That means the x1 has to be very same as x2, and similarly y1 has to be very same as y2. You cannot write like, sir, if x1 is same as y2 and y1 is same as x2, is still left hand side would be equals to right hand side. No, my dear friends. In case of complex equality, its real as well as imaginary part has to be same exclusively towards left as well as right hand side. Towards the left as well as right hand side. So probably till this point each and everything must be clear to all of us. The same thing has to be done over this problem. See what is happening over here. Focus over the left hand side. What I am saying, focus over the left hand side and try to bifurcate this complete complex function in terms of its real part as well as imaginary part. And similarly, once you'll see towards its right hand side, it has got the real part as 0 and similarly the imaginary part as 0. So the part of the real part towards the left hand side would get compared with 0, and similarly part of the real part towards the left hand side would get compared with 0. You will be having the two equations, you will be having the two unknown quantities which are nothing but the x and y. You would be getting their values, and anyways in this problem they were just sticking to get the value of x only. They were just sticking to get the value of x only. So yes, as I have said, you need not to spend much amount of time, just focus over the real part. My dear friends, 3i gets multiplied with the x, obviously it would make a imaginary part. So x into 1 would make a part of real. Similarly, 4i gets multiplied with y would make a imaginary component, whereas 4 into y would make a real part, plus of 5. So you can say when we were comparing the real part both other side, we got x plus of 4y plus of 5 is equals to 0 towards left hand side, and similarly when we'll be comparing the imaginary part, what would be the imaginary part? 3xi. Anyways, 3x has been kept as it is. In future I would be keeping I outside. Similarly here goes 4 iota of y, so 4y can be kept together, 4y can be kept together, and yes, I would be taken separately. So this has gone, that's it. So here it becomes iota is equals to of 0 of I, so iota gets cancels out. So from here the result what we get, it's simply gonna be 3x plus of 4y is equals to of 0. Anyways, my basic interest was to calculate the value of x. So what I would do, in first equation we had the x as well as y, in second equation we had the x as well as y. With the help of second equation, if I convert y in a form of x and if I feed the same result over the first equation, I would be able to get the value of x. Yes. So here the y what we get is simply going to be 3x goes towards right hand side would become minus of 3x, and at denominator it would be 4 now. The same data has to be fed over here. Yes. The same data has to be fed over here, and deliberately the 4 is coming along with this problem such that the y would have 4 at denominator, they would get cancelled out. Yes. So the y has to be fed. The y has to be fed as minus 3x divided by 4. Yes. And here goes plus of 5 is equals to 0. So here the 4 and 4 is getting smashed out. So the resultant what we had is simply going to be x minus of 3 of x. The 5 would go towards right hand side. Yes. And end of the day, x minus of 3x would make it minus of 2x. The minus of 2x has to get compared with the minus of 5. Minus goes off. The x would be simply 5 divided by 2, which is precisely equals to of 2.5. So till this point, probably each and everything must be clear to all of us. Yes, tell me. Is that part clear? Yes. So which page it was? It was page number 38. No, just a minute. Yeah, it was a page number 38. So this many questions we had from the concept of the complex variable. Still I would be taking 1 or 2 more number of problems, but those problems are coming from the concept of calculus, and basically at very beginning I would be focusing over the integral and differential calculus. So the first question comes from the page number 17. Here goes the first question. Yes, it has been a problem from integral calculus. Tell me what would be the most answer for this given problem. The volume determined by the triple volumetric integration of 8xyz dv for v is equals to of 2, 3 cross of 1, 2 cross of 0, 1. What does that mean of it? That means, my dear friends, you yourself would be able to understand. It has been clearly known by visualizing the function for which the integration has been taken place. This has been a Cartesian coordinate function, and hence the dv which we will be taking, obviously has to be a differential volume into the Cartesian domain. What used to be the dv? Each one of us must be knowing about it. That used to be the differential length in the direction of x, y as well as z. And the sequence used to be x first, y second and z last. Once we will be calculating the finite volume, definitely you must be knowing their limits, the lower limit as well as upper limit. As we had the sequence of x, y, z in this way, obviously they have been the limit in this form. So it has been the limit of x, it has been the limit of y, and it has been the limit of z. Yes, that's the standard way to represent the things. That's the standard way to represent the thing. So end of the day, what would be the outcome? My dear friends, we were interested finding the volume integration of a Cartesian coordinate function 8xyz over dx dy dz. So let's start taking the integration from x, and obviously the x would have the limit from 2 to 3. Similarly, let's go towards y. The y would have limit from 1 to 2, and similarly let's move towards z, and the z would have integration from 0 to 1. Anyways, the sequence does not make any sense. The sequence does not make any sense. My dear friends, when the sequence makes sense, when you have a x which has been a function of y or z, if you have a y which has been a function of z, if you have a y which is a function of x, in those sort of integration, there the sequence also make sense. Anyways, I am not going to go into the detailed study of those volumic integration, because that has already been done in case of crash course. So what I am saying, you can see y, x and z. If you will focus over their limits, they have been constant in nature. If they have been constant in nature, what does actually mean of it? You can take the integration in any of the sequence. 8 has been a constant. The integration of x would be leading x square divided by 2. Integration of y would be leading y square divided by 2. Integration of z would be leading z square divided by 2. 2 getting multiplied with 2 and 2 towards the denominator side. Definitely that 8 can be taken out, and so simply 1. It would be simply 1. And now if we will be taking the limit, it would be 2, then 3. It goes from 1 to 2. It goes from 0 to 1. Anyways, rather than spending much time over here, straight away we can get this answer. So x square is simply going to be 3 square. 3 square is going to be 9. 9 minus 4, that simply equals to 5. Similarly, here it's a y square. When the y has been fed as 2, it becomes 2 square minus of 1 square. That is 4 minus of 1, that is a 3. End of the day, it becomes 1 square minus of 0 square, which is simply equals to 1. So the result what we get, it's simply going to be 15. So the bestmost answer what we are getting for this problem is simply 15. Simply 15. Yes. So in the same sequence, we are moving into the page number 25. Just a minute. So here goes the page number 25. And again, it has been a problem from integral calculus. See, the value rounded off to 1 decimal place of the integration from -1 to 1 x of e to the power of mod of x dx is. My dear friends, it has been a bit tedious problem, because absolute value has been the present over this function. Absolute or determinant function has been present over this function. See, you could have solved this problem into 2 different methodologies. See how the x into e to the power of mod of x can be written. It could have been written as x into e to the power of minus of x for x less than equals to of 0, and similarly x into e to the power of x for x greater than equals to of 0. In that case, the integration must have been taken place in parts. Why? Because the function x of e to the power of x has the different nature for the negative value of x, and similarly had the different nature for the positive value of x. And once you see it integration, the integration has been taken place for a certain negative range of x, and similarly certain positive range of x. So what I would be doing over here, the problem would have been -1 to 0, and here the behavior of the x into e to the power of mod of x would have been x into e to the power of minus of x dx. Similarly, from 0 to 1, the behavior of the x into e to the power of mod of x would have been x into e to the power of x dx. You could have get the answer. This could have been the first form. Yes, may I know what would have been the second form? My dear friends, once you will be focusing over this problem thoroughly, you will get to know the f of x which has been taken in this problem is e to the power of mod of x. And now, taking the reference of this f of x, if you calculate f of minus x. What does it mean by the f of minus x? Instead the minus x has to be fed in, and once we do so, e to the power of minus of mod x would make it e to the power of mod x only, and now this minus x would come out, this minus x would come out. What does that mean of it? That means f of minus x stands for minus of f of x. F of x has been an odd function. F of x has been an odd function. Could you understand what I'm saying? F of x has been an odd function, and as the f of x has been an odd function, definitely once you'll calculate the integration from minus a to a, f of x dx, when the f of x is an odd function, the value would be 0. If you want, I can draw this out. If you want, I can draw this out. Yes, taking the reference of just a minute. So let me go back. What was the function x of e to the power of mod x? Now, x of e to the power of mod x. So here goes screen sharing. Just a minute. So here the session is 32. Just a minute. 32235783783. Yes. Let's take the name is Sonal. It's getting connected now. Yes. Just a minute. We'll see how exactly the x into e to the power of mod of x looks like. Another session ID they are asking. Let me feed it again. Here it's gonna be 767123. Present. Start. So you can use the Desmos over here. And you had to draw x of e of mod of x. Let me change the color a bit. So reverse contrast. Here I would be drawing x of, yes, x of exponent, where it is. Let me see where the exponent is. Stats exponent. Yes, exponent of what? Mod of x. Mod of x. So here goes x. Mod of x. How the curve would look like? Yes, the x times of exponent of mod of x. Exponent of mod of x. We had to draw this. So the curve which you will be seeing now. Just a minute. What's the problem we are having? Exponent getting multiplied with. Any mistake is being taken place. No issue. We can do one more thing. Yes, just a minute. Let me check a bit. Here it goes mod of x. Just a minute. No, still it is showing certain problem, but yes, you can assume once you'll see the x of exponent of mod of x, you'll get to know the result would be odd in nature. What does that mean by the odd of nature? The curve would be, what I'm saying, the curve would be symmetrical around the origin, and if the curve is symmetrical around the origin, obviously the result would be 0 area under the curve if you take the same span towards left hand side as well as right hand side. So till this point, probably each and everything must be clear to all of us. And as I have been repeatedly saying to all of you, if you really want to learn mathematics, you should learn mathematics with the help of graphs, specifically the differential calculus, integral calculus, and I can say probability distribution as well as density. Yes, the graphs as well as the understanding of the graphs are very important. Anyways, we would be meeting in the next video. The agenda would be almost same. We would be going into the next topic of the engineering mathematics questions which have appeared in GATE year of 2021. Till then, bye-bye, take care and keep studying. Bye-bye, good night.